Good day, class! So for today, we need to discuss about how to solve quadratic equations using extracting of roots. But first, there's a manual activity on how to solve equation with one unknown. Click the quizz's application link and try and solve the following questions. Good luck! Did you get it right? So what is your score? So after we solve equation with one unknown, let's now move on to solving quadratic equations using extracting of roots. So terms to remember that the standard equation or standard form of the quadratic equation is ax squared plus bx plus c is equal to 0. So in solving extracting of quadratic equation using extracting of roots, we need to remember that b is always equal to 0. So our quadratic equation now will become ax squared plus c is equal to 0. And in terms to remember, if the quadratic equation is equal to x squared equals to c, so if c is greater than 0, we only have two real solutions. If c is equal to 0, so we have now one real solution which is equal to 0. And if c is less than 0, we have no real solution. To further understand the lesson, so let's say we have the first example which have an equation of x squared is equal to c. So let's say we have x squared minus 9 is equal to 0. X squared minus 9 is equal to 0 is a standard form of a quadratic equation. So to solve this one, we need to transform this equation into this form. So x squared, we transpose now 9, so it will become now, from negative it will become positive. So x squared is equal to positive 9. So to eliminate the second degree, so we square root. So square root of x squared is x is equal to, again remember that if we multiply if we square positive 3 or negative 3, the answer is always 9. So it means always 9. So it means that the square root of 9 is always positive or negative 3. So in other words, the roots or the solution set of x squared minus 9 equals 0 are x is equal to positive 3 and x is equal to negative 3. In our previous example, so our x squared doesn't have any numerical coefficient. In our next example, our x squared now have a numerical coefficient a. So we have now the equation ax squared is equal to c to solve the equation or to find the roots of the equation. So for instance, we have 4x squared minus 16 is equal to 0. So again, this is in standard form. So we need to transform this into ax squared equal to c. So where a is your 4, negative 16 is your c. So first, again, we transpose negative 16. So from negative 16, it will become now positive 16. So we have 4x squared is equal to positive 16. Now, take note, we have the numerical coefficient for your x squared. So, you need to eliminate first your numerical coefficient before we go to our square root. So, we divide both sides by 4 using multiplication property of equality. So, we cancel this out. So, we have now x squared is equal to 16 divided by 4. So, we have now 4. Now, we can now get the square root of both sides to eliminate the second degree. So we have now square root of x squared and square root of 4. So square root of x squared is x is equal to, again from our previous lesson, if we take the square root of a number, it will become now positive and negative. So it means square root of 4 is or are positive and negative 2. So it means that the solution set for 4x squared minus 16 are x is equal to positive 2 and x is equal to negative 2. Let's have a different approach, different example. So we have now m minus 4 quantity squared is equal to 169. So as we know that to solve the quadratic equation using extracting of roots, it's either x squared is equal to c or ax squared is equal to c. So we need to transform this equation first in either both ax squared or x squared. So first, as we can see, m minus 4 squared is equal to 169. So we need to eliminate the second degree. So again, m minus 4 quantity squared is just one term. Imagine this as your x. So it means this is your x squared. Your m minus 4 is your x squared. Your 169 here now is your c. So still we have the equation or quadratic equation x squared is equal to c. Again, your m minus 4 is just one term, which is x. So it means your m minus 4 will become your x. So that will become your x squared. And your 169 now is your c. So it means this is a quadratic equation. So to solve for this one, so we need to eliminate the second degree because this is only one term. So it means m minus 4 squared is equal to square root of 169. So m minus 4, so we eliminate the second degree. So we have now m minus 4 is equal to, again, or 169 now will become positive or negative 13. So we have now two equations. What is the two equation? First equation, it is m minus 4 is equal to positive 13. And the second equation is m minus 4 is equal to negative 13. As you can see now in our previous lesson, this is solving equation with one unknown. So we have one unknown. So your unknown here is m. So in your first equation, so you need to isolate letter m. So we need to transpose now your negative 4. So it means positive 13, it will become now positive 4. So m is equal to 17. This is now your first solution set. Next, for the second solution set, we have m minus 4 equals negative 13 from your square root of 169. So it means, again, isolate letter m. We transpose now negative 4. It will become now positive 4. M is equal now negative 13 plus 4. So do your integers. So negative 13 plus 4, it means negative 13, means 13 minus 4, copy the sign of the larger number. So 13 minus 4, we have now 9. We copy the sign of the larger number. So we have negative 9. So it means the second solution set of m minus 4 quantity squared equals 169 is negative 9. So it means your solution sets are 17 and negative 9. So for our next example, so as we can see now, the equation again now is that on x squared plus c is equal to 0 or not in quadratic equation. So again, to extract the roots, so we need to transform this equation into quadratic equation. So as we can see, x plus 5 is equal to 4 over x minus 5. So we need first to eliminate the denominator. So we multiply both sides by x minus 5. So that is the multiplication property of inequality. So x plus 5 times x minus 5 will become now, we cancel this out, is equal now to 4. So as we can see, x plus 5 and x minus 5 is sum and difference of two squares. So again, square the first term. So we have now x squared, then square the last term. We have now 25. Then copy the minus sign or the subtraction sign. It's equal to 4. So now we're gonna transform the equation into what? X squared is equal to c. Again, isolate letter x or isolate the variable. So we again transpose to negative 25. So it becomes na x squared is equal to 4 plus 25. So x squared is equal to 4 plus 25. So we have x squared is equal to 29. So again, we can now get the square root to eliminate the second degree. Square root, then we have the square root. So x will become now square root of 29. 29 here is not a perfect square, so it means we have now plus or minus square root of 29. So it means the roots now are positive square root of 29 and x is equal to negative square root of 29. So another situation now. So we have now 4x squared minus 45 is equal to 0. So as you can see, it is already now in quadratic equation. So again, to solve this one, so we have now 4x squared equals, again we transpose 45, negative 45, so it will become now positive 45. So as you can see in the last example, so you need to isolate letter x or the variable. So you need to eliminate the numerical coefficient. So we divide both sides by 4. So we have now x squared is equal to 45 over 4. Now, you need to get the square root to eliminate the second degree. So this will become now x is equal to, so we can, in rules of radical expression, this is the same as square root of 45 over square root of 4. So we have now plus or minus. So as you can see, so we have now x is equal to what? Square root of 4 or 4 is a perfect square. So we can now say that 4 will become now positive 2. Next, 45 here can be rationalized. So you need to rationalize 45. To rationalize 45, you need to find any factors of 45 that has a perfect square. So ano po yung factor niya doon? So we have now 9 times 5. 9 here is the perfect square. So it means the rationalized form of 45 now would become square root of 9 times 5. So 9 here now is a perfect square. So it will become now 3. So the square root of 9 is 3. Square root of the remaining radical number, which is 5. So it means that the solution set for 4x squared minus 45 equals 0 are x equals positive 3 square root of 5 over 2 and x is equal to negative 3 square root of 5 over 2. So another example now is 2x squared minus 9 is equal to 0. So again, that is now in ax squared minus c plus c is equal to 0 or already in standard form. So again, so we have 2x squared. Again, we isolate the variable. So we have now transpose 9. So we have now positive 9. Eliminate now the numerical coefficient. So divide both sides by 2. So we have now x squared is equal to 9 over 2. So we take the square root. So we we have now x is equal to, get the square root of 9, which is 3. And 2 here is not a perfect square. So it means we have x is equal to plus or minus 3 over square root of 2. But, again, in the reminder, you cannot have a radical number that is a denominator. So it means that this answer is not rationalized. So we need to rationalize the answer. So to rationalize, multiply both sides or multiply the number to its denominator, which is square root of 2. So we have now x is equal to 3 times square root of 2. So we have 3 square root of 2. Square root of 2 times square root of 2 using law of multiplication of radical numbers. So it means that is 2 times 2. So 2 times 2 now will become square root of 4. 4 now is a perfect square. So it means that your final answer now will become 3 square root of 2 plus or minus over the square root of 4, which is 2. So it means your solution set or your roots now for 2x squared minus 9 equals 0 are x equals 2 plus, positive 3 square root of 2 over 2 and x equals negative 3 square root of 2 over